The last video was about my final servo motor adapter design as I asked your feedback. And you replied a lot in a really good way, which was exactly what I was hoping for. I got really good technical feedback that I was actually able to use in a completely new redesign. This redesign became much simpler with fewer parts. And the biggest difference is that I can make these parts myself now. Probably because it's been a while since I have machined parts this precise. There were a lot of suggestions and more than I was expecting, honestly. Most of them I'm still thinking about, but two really changed my thinking right away. The first was to look at a double row bearing, similar to what you'd find in a car wheel hub. And once I got that comparison to a car wheel, my earlier hesitation of using a double row bearing just completely dropped. The second was that all critical surfaces should ideally be machined in a single setup. That way you know they are aligned regardless of any small deviations in the individual parts. This is the new adapter design. And the first thing you might notice when you compare it to the old adapter design is that it looks a lot less impressive, which is exactly the point. The old design had a hub wrapping around the flex coupling, it had two separate ball bearings, it had a bunch of rings, and all in all it was just starting to look like something from a spacecraft. The new design just has a single double row bearing, it still has the same flex coupling, it has two housing parts, a shaft with a spacer ring, and that's basically it. The housing consists of two parts. We have one square part that matches the motor flange, and we have one round part that houses the bearing. Now, if I'm being completely honest, before I decided to make these parts myself, I wanted to give Xometry a go. But then I got the quote. For two parts, so just for a single axis, the price came out to around 700 euros. And I want to be fair about this. It's probably a fair price and Xometry isn't doing anything unreasonable. You're paying for precision work, setup costs, programming, a small series and fast turnaround, and that just has a price. But for this project, it's just hard for me to justify, so I'm going to put my hesitation aside and try to make these parts myself. After all, I've got most of what I need right here. I've got a lathe, I've got stock to make the shaft, I've got stock to make the timing belt pulleys, the bearing has already arrived, and on Monday I will order the aluminium to make the housings here on the lathe, and I'm also going to need a longer and more rigid boring bar, because the ones I have are just too short and not rigid enough for this job. One thing I was glad to find before ordering a new one is this tool for cutting internal curl-clip grooves. And the best thing is I only have one of these and it's even the right size. How nice is that? And then there's this! This is my drill press. I know it's not an Altmetall, but it does what I need. It makes holes. And there is one thing I'm probably going to run into in this project. My lack of skills with the lathe. It has been a while since the two of us tangoed together, and I suspect the lathe is going to remind me of that. There are two things I don't think I can make myself. The internal keyway in the timing belt pulley and the keyway in the shaft. Maybe I will find a way to make these myself anyway, maybe I don't, time will tell. And then there are these 4 corner radii on the motor side. I can make these either with a file or here on my belt sander. It sounds primitive, but as long as those radii roughly match the motor flange, it's fine. It's finally time to make some parts and probably start over a few times. Either way, you will see some machining in the next video. If you have questions or spot something I'm missing, let me know in the comments. I genuinely appreciate it. See you in the next one.